My subject is elements of mechanical engineering, semester 3rd. My topic is hydrokinematics. In this topic, today I solve a problem of continuity equation. So my question is, the diameter of a pipe at section 1 and section 2 are 10 cm and 15 cm respectively. Find the discharge through the pipe if the velocity of water is flowing through a pipe at section 1 is 5 meter per second. Determine the velocity at section 2. So in the previous class we discussed about the continuity equation. So what is continuity equation? Q equal to A into V. Discharge equal to area into velocity. So in this question we solve it. First is the diameter of the pipe is given. Diameter of the pipe is how much? 10 cm at section 1, then diameter equal to 15 cm at section 2. So that is a varying cross section, the diameter is increasing. So this is your section 1, this is your section 2. So that is diameter is given. So d1 equal to 10 cm, we convert into meter, that is 0.1 meter. Then d2 equal to 15 cm, that is 15 divided by 100 meter equal to 0.15 meter. So that is 0.1 meter, that is 0.15 meter. Then find the discharge through the pipe velocity of water. Section 1 का velocity is given. Velocity at section 1 is 5 meter per second. To be determined, what? Velocity at section 2 and discharge Q. So we know the formula is Q equal to AV, or we can write Q equal to A1 V1 equal to A2 V2. That means discharge at section 1 and section 2 is given. So here the diameter is 10 cm and here the diameter is 15 cm. Here the velocity is how much? 5 meter per second. Here the velocity is calculated. So determine, so first determine the area. A1 equal to pi by 4 d1 square, then pi by 4 d1 equal to 0.1 square. Then next you can move to A2 equal to how much? Pi by 4 d2 square, that is pi by 4 1.5 square. So here you calculate the value. So how much that area is? How much? The area is, after calculation we get the area is 0.00785 meter square, and A2 equal to 0.1 0.0176 meter square. So Q equal to A1 V1, that is given. So A1 equal to 0.00785 into V1 equal to 5 meter per second square. So here you can calculate the discharge meter cube per second. That is the task of the student. They can determine the discharge. After getting discharge, according to question, we know Q equal to A1 V1 equal to A2 V2. So they can calculate the equation Q equal to, after getting Q, they can calculate the A2 V2. So from that they can calculate the velocity at section 2, or they can calculate the equation A1 V1 equal to A2 V2. The value is given here, unknown is V2. So how can calculate the V2? The V2 equal to A1 V1 then A2. A1 value is given, that is 0.100785 into V1. How can calculate? 5. Then A2 is given 0.01767. That is that much meter per second. So from that equation they can calculate the Q, that is discharge. And velocity at the section 2. This is the task for the student. They can calculate the velocity and the discharge. Then, so here we can calculate the two things. One is your discharge, another velocity. Now you go for the second question. So in second question, one question is, water flows through a pipe. AB is 1.5 meter dia. When the velocity is 3 meter per second, and then passes through a pipe BC equal to 1.5 meter dia at C. The pipe branch CD 0.8 meter in diameter and carries 1/3 of the flow of AB. The flow velocity in branch C is 2.5 meter per second. Find the volume rate of flow in AB, velocity in BC, velocity CD, and the dia CE. So according to question, first we understand the question, what is the given, what to be determined. So here water flowing through a pipe AB. In question that is given water flowing through a pipe AB, that is given AB. The pipe is given. Then again the pipe diameter is increases, that is BC, and the what is the value? Diameter is 1.5 meter. Here the diameter is 1.2 meter. Here the diameter is 1.5 meter. Then at C the pipe branches branches CD, another is your CE. CD, the diameter is 0.8 meter, carries 1/3 of the flow. That carries 1/3 of the flow. The flow velocity at the CE. In CE, the velocity is how much? In CE, determine the velocity, that is VCE. So to define the volume rate of flow, so here what to be given, we can write data given. First we write the data given. In data given, the diameter of AB is given, that is 1.2 meter. Then also velocity of the AB is given, that is 3 meter per second. Then diameter of BC is given, that is 1.5 meter. Then diameter of CD is given 0.8 meter, and flow of CD, Q में कितना फ्लो करेंगे? QAB का 1/3. QCD, how much water is flowing? QAB divided by 3. So diameter of AB is given 1.2 meter, velocity of AB is given 3 meter per second, diameter of BC is 1.5 meter, velocity of CD is 0.8 meter. Then water, how much is your fluid is flowing? Water is flowing, that is CD equal to 1/3 of QAB. So here we determine the discharge. We determine the discharge of AB. Here we determine the discharge of AB. Then velocity of BC. We determine velocity of BC. Then velocity of CD. Then diameter of C. So first you read the question 2 or 3 times, then understand the question, what is given and what to be determined. So here that is given a pipe, that is AB, then the diameter is 1.2 meter and its velocity is 3 meter per second. Then pipe diameter is increases, that is 1.5 meter. Okay, then the pipe branches at point C. One is CD, another is CE. In CD, how much water is flowing? 1/3 of the AB. AB में जितना फ्लो करते हैं, CD में उसका 1/3 फ्लो करेगा. So after getting that, we can determine discharge at AB, velocity at BC, velocity at CD, and diameter of C. And next class we solve the problem. Okay, thank you.